why you're doing that? Say it again.
Multiply the coefficient by 3.
You're multiplying the coefficient by 3. Yeah. Oh, sorry. I see what you're doing. Yeah. Sorry. I was skipping steps. Okay. And now what? Is that right? It's kind of not. What's the problem with this? I'm the problem. Okay. The problem is actually this has to be 100. Yeah. So actually, no, what have I got? I've actually, oh no, this is 100. I just wrote that's 100. That's 100, which is makes, that's why I've written 100. That's why it's going. Don't worry, I've got it now. Okay, yep.
H over 10, how do you get 100? Where are you getting 100?
10 squared. Square top and bottom. Yes. No, because this square just belongs on that. Yeah. Okay. All right. So let's go over here. So what we found is dVdh, but we want dH/dV. So what did you say before we're going to do, Addie? We're going to inverse it. So we get 100 over 9 pi h squared. All right. And then we want the volume with respect to time. Do we have that or do we need to work it out? Yeah, it's the rate. It's this over here. Okay. So this is just multiplying it by half, right? Oh, okay. I have missed one tiny piece of information here. Okay, let me think about this. What did we do in the last question? Increase. This is decreasing. So I'm just going to make that negative because we're decreasing. So if we are halving this. Okay, now we can think about what we're doing before. What we want is to find out what the rate is at a certain point. So what do I do now? Yeah, now I use the 2 centimeter thing. So if we go back up to this, it told us that the depth is now 2 centimeters. So now that we have this, it's negative 50 over 9 pi times 4, because 2 squared is 4, which gives us negative 50 over 36 pi, which simplifies to 25 over 18 pi. Negative. Now, it depends how you write the answer. This is the answer, but all it says is find the rate, the depth is decreasing. So you would say the rate is decreasing. Oh, sorry, not the rate, the volume, depth, yeah. The depth is decreasing at a rate of 25 over 18 pi centimeters cubed per second. I don't need to write negative because I've said the word decreasing, right? But a negative answer tells you that it's decreasing. Yeah. Yeah. It's volume because the depth is oh, no, that's a really good point. Yeah. It should not be, it's the depth, isn't it? Which is a length. So excellent point. Okay, I am so sorry that is terrible. I am going to do, I feel like I need to do one more example of that because it's really hard. Yeah, but the problem is I need to move on to something even harder. So, oh, it gets worse. Oh, I don't want to do that one. Oh, you know what? I will. I actually will upload myself solving all of them, but I need you to actually practice them. Okay. You know what I think is a really... Okay, I might have a better idea of how we can use our time. we've already had half the lesson. Okay. I am going to tell you today that you only have to do. Oh, can you come back in 5?
Can we not
Yeah.
do this?
This is the only day. Come back in 5. They'll do it for 2 seconds. Okay. I am going to ask you. Okay, I'm going to give you one more example, and then I'm actually going to only set you half the questions, and I'm not going to make you do the worst part. Okay.
Well, then,
I'm going to ask you. Yeah, I know. I'm going to rearrange some stuff. Okay, let me think about what other question I had. All right, let's do this example. Okay. Radius of a circle is increasing at a rate of
It's next week.
Wednesday as well?
okay, let's talk about it in a second.
When we have this.
Okay, let's have a look at this example. Let's do another one. Guys, stop. We'll talk about it in a second. Let's just do this other example. Okay, focus. Focus. So I am asking, you can ask a question in a minute. Let me just go through this example, then we'll talk about it next week. I am being asked to find the rate. The area is increasing at this point. So I want the area in respect to time, right? So I'm asking for the area in respect to time. So this is going to be A, this is going to be DT. What's the other thing that I can use? The radius. All right, so the radius is the other thing that we're talking about. We were looking at how this is increasing, how it affects the area. All right, so we know that the radius as it affects time, right? So the radius with respect to time is 2 over r squared. Yes? How do I rewrite this? Not as a fraction. Okay. Oh my goodness. All right, so let's derive this. What's the derivation of this? Yep. -3. All right. So now we've got this. Actually, oh, no, we don't need that. What a silly thing for me to say. Actually, let's just leave that. Sorry. DRDT. Sorry, we don't actually need to do that. My bad. I'm wasting time. Okay. What I do want to work out is, so what's the area of a circle? Okay. So what we need to find is, so sorry, this is what this is. This is already a rate of change. I'm so sorry. All right. So what we actually want is the area in respect to the radius, right? So what's that? Right, you bring the 2 down, subtract by 1, right? Because I want the area with respect to the radius. Okay. So I have asked for that, which is this 2 pi r, with respect to what I was given over here.
Wait, you need to add up.
What's the difference between area and area with respect to radius?
Yeah.
So I'm looking for a rate of change, right? That's what, so remember when we find gradients, when we find derivatives, we're finding gradients, which is the rate of change. So you want the equation of the rate of change, which is what the derivative is. That's why we have to find it. Yeah.
Why do you need to change? Wouldn't it just be easier to come up with an equation and then derive the equation?
It doesn't work that way. Because that's not how calculus works, I am afraid. All right, so then we have 4 pi over r squared, right? Oh, sorry, 2 pi r, 4 pi r, right? Which gives us 4 pi over r. Good. All right. What do we do next? Yeah, substitute what? Okay, so we know that r is 8. So then we have 4 pi over 8, which is half pi or pi on 2. Either way, makes no difference. But we want to write it. So pi over 2, and it is meters per second. Now, the book is being a bit weird where sometimes, what are we doing? We are finding the rate, the area. Yes, you're right. It is squared. The book is doing a thing where sometimes it gives you the answer to 3 significant figures, and sometimes it leaves them like this. I would prefer for you to leave them like this, because I think that's more likely in an exam. If it says round to 3 significant figures, then of course do that. But if it doesn't tell you to round, leave your answers in exact form. That would make more sense to me. All right, I get that this is really hard. So what I'm going to do, I'm going to stop the recording.